NASA is well known for its space exploration and discoveries. On the other hand, the agency finds findings beneath the Earth right here on the globe. One of them is a fascinating new find beneath Antarctica's ice, with experts rethinking their perspectives on the planet. So, what has NASA found out? Is it having an impact on you? Join us as we investigate NASA's odd new find beneath the ice of Antarctica. Of course, it's reasonable that a few individuals consider Antarctica to be a dream vacation. Antarctica is the world's fifth largest continent with an area of approximately 5.4 million square miles, 14 million square kilometers. However, the continent's size changes with the seasons since increasing sea ice along the coast doubles its winter size. Almost the whole continent of Antarctica is covered in ice. In fact, fewer than 5% of the remote wilderness is ice-free. In an area slightly under 1.5 times the size of the United States, this location houses 90% of the world's ice. The temperature is so low that if you toss boiling water into the air, it will rapidly evaporate because most particles will transform to steam while the remainder will turn to tiny ice crystals. East and West Antarctica are the two sections that make up the continent. East Antarctica is around Australia size and comprises about 2/3 of the continent. The average ice thickness in this continent section is 1.2 miles or 2 kilometers. West Antarctica is a chain of ice islands that stretches from the southernmost tip of South America to the southernmost point, constituting an extension of the Andes Mountains. The Transantarctic Mountains divide the two zones, spanning the continent and occasionally entirely covered in ice. Is there any vegetation in Antarctica? In specific ways, yes. It consists of only a few mosses, lichens, and algae. Over the last 50 years, the amount of seasonal moss in Antarctica has progressively grown. Animal life is far more plentiful despite the lack of amphibians, reptiles, and terrestrial mammals. Many penguins, whales, fish, and crustaceans thrive along Antarctica's shores and icy oceans, especially in the summer. What about human existence on this vast ice sheet? While there are no indigenous peoples in Antarctica due to the severe climate, up to 4,000 visiting scientists may be found spread out among 70 research sites in the summer, surviving the cold on the continent. During the much more brutal winter, that number lowers to 1,000. Climate scientists, oceanographers, and marine biologists primarily use Antarctica as a research base. On the other hand, the frozen desert draws astronomers from worldwide. Antarctica is one of the finest places on Earth to watch space, provided that you can stand the cold. It is due to the area's dry climate and lack of light pollution. When it comes to observing space, NASA, the monarch of the cosmos, is involved. In Antarctica, what has NASA been up to? Looking down from above, the Antarctic ice sheet appears to be a tranquil, permanent ice blanket that has blanketed Antarctica for millions of years. But don't be shocked if the ice sheet is thousands of meters thick at its thickest point and covers hundreds of meltwater lakes where the continent's bedrock meets the ice sheet. Scientists have enhanced their maps of these remote lake systems beneath the West Antarctic ice sheet using the most potent Earth-observing laser equipment NASA has ever flown in orbit. They have identified two additional active subglacial lakes, Conway and Mercer. The new research is essential for recognizing fresh subglacial lakes from space and determining how this secret plumbing system affects the rate at which ice falls into the Southern Ocean, adding fresh water that might disrupt the ocean circulation and organisms. Scientists have precisely mapped the subglacial lakes using NASA's Ice, Cloud, and Land Elevation Satellite 2, or ISAT-2. Despite its immense thickness, the satellite measures the ice surface's height, rising and falling as lakes fill and empty under the ice sheet. The research, published in Geophysical Research Letters, combines height data from ISAT-2's predecessor, the original ISAT mission, and Cryosat-2, the European Space Agency's polar ice thickness monitoring satellite. For decades, the hydrology systems beneath the Antarctic ice sheet have remained a mystery. That began to change, though, in 2007, when a glaciologist, Helen Amanda Fricker, at the University of California San Diego Scripps Institution of Oceanography, produced a discovery that helped update the traditional knowledge of subglacial lakes in Antarctica. Fricker Whitaker discovered for the first time using data from the initial IceSat in 2007 that underneath Antarctica's fast-flowing ice streams, a complete network of lakes joins actively filling and draining over time. These lakes were formerly assumed contained meltwater in a static state, not filling and emptying. The first ICES mission is credited with uncovering the linked networks of lakes that move water around at icebed interface, allowing scientists to investigate all aspects of glaciology, microbiology, and oceanography. Scientists now acquired a potent instrument in IceSat-2, which provided data with such high accuracy that they could begin mapping out the lake borders on the surface. Subglacial water exchange in Antarctica, according to scientists, is caused by a combination of factors. It includes variations in the pressure exerted by the massive weight of the ice above, friction between the ice sheet's bed and the rocks beneath, and heat rising from the earth below that is insulated by the ice's thickness. It is in sharp contrast to the Greenland ice sheet, where meltwater drains through cracks and holes in the surface, filling lakes at the ice sheet's bed. How deep are the Conway and Mercer lakes beneath the surface? On the southernmost continent, these secret treasures of icy water are concealed beneath 1.2 to 2.5 miles, or 2 to 4 kilometers of ice. They fill and drain in irregular cycles that may impact how rapidly the ice sheet moves and where meltwater enters the Southern Ocean. This movement in turn can alter Southern Ocean currents and so global ocean circulation. Unlike most surface lakes which remain stationary for years, this subsurface water system is dynamic or highly fluid. Scientists followed changes in the subglacial lake system between 2003 and 2020 by merging data from various satellites. The boundary between the Mercer and Williams ice streams in West Antarctica, the lower McHale ice stream in West Antarctica, and the upper Academy Glacier in East Antarctica were chosen because they had high satellite coverage and known active lakes. The researchers discovered 2 new lakes along the Mercer and Williams boundaries, named the Lower Conway Subglacial Lake and the Lower Mercer Subglacial Lake. They also found 2 lakes beneath the McIsle ice stream rather than 1. These lakes have changed dramatically throughout time. Researchers are already discovering connections between the under-ice lakes and the ocean. For example, according to Live Science, research co-authored in January last year found that the draining of one lake on the Amory ice shelf in East Antarctica discharged as much as 198 billion gallons or 750 billion liters into the ocean in only 3 days. While discovering lakes buried deep beneath the ice in the Antarctic is exciting, you may be wondering if there is life in those lakes. The climate is severe enough on the surface, but can life thrive deep within the 2 freshly found lakes? Early examinations of water samples obtained from Lake Mercer revealed that they had around 10,000 bacterial cells per milliliter, according to expedition leader John Priscu, a professor of Arctic ecology at the University of Montana. Now, while this is just around 1% of the 1 million microbial cells per milliliter seen in the open ocean, it is nonetheless a stunning find for a secluded body of water buried behind an Antarctic glacier. However, the high levels of bacterial life in the dark and deeply submerged lake indicate that it may host higher life forms, such as tardigrades, which are tiny little creatures. Meanwhile, the discovery of high levels of bacterial life in Lake Mercer paralleled high levels of bacterial life in Antarctica's adjacent subglacial Lake Whillans in 2013, which Priscu also led. The bacteria in Lake Whillans and perhaps Lake Mercer are thought to be thriving on carbon deposits left by photosynthesizing species between 5,000 and 10,000 years ago, when the sunken lakes were linked to the open ocean. The expedition team utilized drills and hot water to dig a borehole from their tent at the frozen surface down to the hidden lake of liquid water during their stay on the ice from mid-December last year. The drill crew drilled through around 3,504 feet, or 1,068 meters of ice, where the water was a cold 30.8 degrees Fahrenheit minus 0.65 degrees Celsius, allowing scientists to collect water samples and sediment cores from the lake, which was about 49 feet, 15 meters deep at the time. The crew had also dropped a sophisticated, remotely operated underwater vehicle, or ROV, and numerous cameras into the murky waters of the submerged lake, which they used to collect photographs and create a movie of the lake floor. The discovery has ramifications for the hunt for life on other worlds, notably on Mars. Data from the European Space Agency's orbiting Mars Express probe revealed hints of a subsurface lake of liquid salt water in 2018. Priscu believes that any life found beneath the icy surface of Mars might be similar to that found in Antarctica. Antarctica's subglacial lakes. So let us know your thoughts on NASA's discovery of signs of life on Mars in the comments box below. Remember to strike a like and hit the subscribe button to have upgraded updates. Never miss sharing our links to all of your networks.